Okay, we're going to look at an ammeter now. That's the symbol we're using, big A for ammeter, pretty straightforward. Here's the type we would use in the lab. It's another analog one. It's got the little needle, will deflect to whatever the corresponding current is going through it. Okay, and it's got to go through, so we're going to put the ammeter in series with a circuit to measure the current that goes through that circuit. As you can see, similar to the voltmeter that we had, you've got different gauge numbers here depending on how much current you got going on. The 50 and 500, those are measured in milliamps here, so those are going to be smaller amounts of current, and you can go up to 5 amps DC here, direct current. Again, there's the common, that's going to be the lowest potential connection. What we're going to look at here to see how this runs is I've got my good old, we've got a lamp here, and I've got connected to just a 1.5 volt battery, one of the D cells here, like that. So I've got one end terminal going to the positive. Current's going to come out around, go through the light bulb. We need to collect that current coming out of the light bulb here, and that's going to go into our positive terminal. I'm going to start out at the middle one right now. I'm sure it's not going to be 5 amps. You're never going to get 5 amps out of a D cell battery. Okay, so when I connect the bottom negative terminal to the ammeter here, common terminal, you saw the deflection right there, and it looks like it's someplace, well, it's really close to 50 milliamps. We're using the 500 here, so we're using the top numbers. It would be 0, 100 milliamps. We're just past halfway, so we're actually over 50 milliamps. So if I put it into the 50 connection, it's going to deflect too far, and you don't really get, maybe I took a little more out of the battery, and now I've got at 49 milliamps. So you get a better reading, like I said, with the voltmeter, better reading on the deflection here. The greater deflection, the better, the more precise the reading is going to be. So that's how you use this guy here. Another example of meters that we don't usually use in most of our hands-on labs is going to be a multimeter. It does multiple different kinds of measurements. This one here is the digital one. I also have an analog that just has a needle deflection on there. Similar amounts. You got a common, that's the black excuse me, negative terminal. Whatever the higher potential terminal is going to be this one. If you get larger amperages, larger currents that you need to measure, you can go up to 10 amps into this one, just to protect the circuitry. You know, you get too much current in some of these circuit boards and stuff, it'll burn out. So this can handle higher currents. All right, so basically it's the same old as this one here. Let's just see how it works. We were doing current here. We had, it was 50-ish, so we're going to go on to 200 milliamps right there. And let's see if I can turn this on. I want to go from, I want this one to connect to the battery, the negative to negative, and then connect the positive terminal here, and I should get a decent readout. You got too many wires here, but nature of the beast. And when we click that on, now we get 51.3. So I think the battery had a little bit of time to juice back up when I was switching over to this one. If I let it go a little longer, it'll probably drop down somewhat as the battery gets used up a little bit more. So just another option.